First thing I found, I might have covered these in the past, but these are a set of transfer gauges, and these are the kind that just fit in the hole. They're sort of a plug style. You've got a hole and you want to take a part and you want to transfer, set that part down and find the center of that hole on the bottom part like this. That was a lucky guess that fit. In any case, this is a really nice tight fit there. Put it upside down, tap it with a hammer, and it'll mark the center of where that goes. Presumably there'd be more alignment options available. Now this is one style, again, for just holes to match them. If you happen to have threaded holes, I got this set very recently. I got these a while ago. These are a set of all different sizes. Here's a 3/8 24. So inside each one of these, they come with a bunch of these little transfer hardened set screws. So you thread this guy in, and if you're wondering how you put it in, you notice there's threads. So this guy would be the part that's facing out with the hardened steel point, but each one of these has the tool to screw these in. So this should fit in the end here. It looks like there's a little bit of burrs on there, but that's on there. And you'd use this tool to tighten that in, and it comes with I don't know, this one has six total in there. And so if you have a whole variety of these in different sizes, which I bought, I got a really good deal on used sets of these. Very handy if you need to transfer threaded holes from one part to another. This set goes all the way up to 1/2 13 and all the way down to, well, that's 540. I thought there was 440 in this. Maybe it goes only down to 540. That's 632. So 540 is an interesting size and not too common. And it looks like it has just 2 in there. There's the little transfer punch, and again, the tool to tighten them in is built into the front. See, just thread it right in. So pretty handy to have around. You don't always need this sort of thing, but when you need it, it's really great to have, because estimating the center of a threaded hole or even a regular hole with normal tools can be a bit of a pain in the butt. So this can simplify things a whole lot. One more thing, I store all these together in this box that this set came with. If you're interested in seeing them used, the first time I ever saw them used was Adam over at A-Bomb 79. Adam Booth has used them on several projects. Come in really handy. So you can head over there and check out his videos if you want to see them in product in use. Next up, we have a selection of carbide reamers. So I bought all these in a lot. They were listed as small carbide reamers. They all seem to be in pretty darn good shape. These are pretty sharp. And you know, if I'm in a real hurry, obviously I have to buy from the, you know, the big vendors, but you pay a real premium. So when I get the opportunity, if I run across a really good deal, I'll buy a lot of them just to get a few sizes. I think this was like 50 bucks or something like that. Well, a carbide 1/4 inch reamer, this is a 0.2508. This could be close to 50 bucks all by itself. That's a GAR. So even if you just get one, here's 0.253. There's a couple 2 millimeters in here, and there's a 0.125. Some of these are kind of hard to read. Number 10, well, that's a number 10 drill bit equivalent. That's interesting. So anyways, just pointing that out. Of course, now I'm giving you my secrets. Now these lots will probably become really scarce as everyone goes out and finds them themselves. Another lot of these reamers I bought, these are non-carbide, was to get one particular size. So this is a 5/8. I didn't have a 5/8 reamer. These were going for a really good price. I can't remember what they are. They're new. 0.6299. There's an oddball. Probably won't use that one for a whole lot. .7/8. So 2 normal sizes and 1 not so normal size. Again, bought it for 1 specific size. The other 2 were a bonus. So even if I don't use this one, it still could come in handy. Next up, something a little mundane, is a grease gun. So I bought this one, I forget where. It's a really inexpensive one. I tried to buy the best one I could find at the time. The end here really catches on the Zerk fittings on my mill, and I actually have had to pry this off before. It may have an adjustment. I didn't realize they did have adjustments, but this one might have an adjustment back here. But I found a replacement for this that I think is better made. So I looked around, and this one seemed to be better made than most of them. This is a McNaught, and it came straight from the vendor. McNaught is an Australian company, and everything looked pretty solid on this one. Got good recommendations. You could buy it either with a fixed or a flexible hose that has the same sort of fitting on the end that may give you problems. Part of the deal I got with this one was to get their safety grease coupler, and this one has a quick release end, so no more catching on Zerk fittings. So I'll probably be taking this one off and putting this one on. So the normal use obviously is to grease your tools, but another use for a grease gun that may not be so obvious, I'll explain further. This grease gun takes both bulk or cartridge grease, so you can either unscrew this, put a cartridge in, or just pack grease into this tube, and it'll pump it right out for you, and still seal the end and not have it leak out. Now these things can generate quite a few thousand PSI of grease, so a not so common use for them is if you want to use high pressure fluids, quote unquote fluids, to deform metal. So I watched a guy that created a fixture, and he wanted to create a dome in some stainless steel, and he wanted it to be essentially seamless. And what he did was he created two pieces of metal that would bolt together, that had the center part cut out on one of them, and a Zerk fitting on the back or the side that fed grease in behind. And what he'd do is he would take a sheet of stainless steel, like, I don't know, 12 gauge, 16 gauge, something like that, and he would bolt it through on the outside. It had like one bolt every inch or so all the way around the circumference, and tighten it down. And then he would pump grease into the back, and a couple thousand PSI, it made the grease, it made the stainless steel sheet bulge out and conform to the shape that he had on the other side. Now, he had one side open, so it formed a dome, but you also could have had it into a mold and press the stainless steel into a mold. In his case, he was using it to make a headlight for a motorcycle, if I remember right, the rear portion. And it turned out really good. I was totally amazed at the quality. So when he was done, all that grease that got pressed in behind the stainless, he just scooped it out, put it right back in his grease gun, and off he went. Obviously had to clean the part, but it's a really cool way to do it. So I took the original Zerk fitting attachment off, and I'll keep that, and I put the quick release one on. Very smooth. This is the lube I've been using, Molygraph multi-purpose. Has molybdenum disulfide in it. Load that in first. Supposedly pop this guy off and thread this guy back in there. Now, if it's really cold and the grease is extremely viscous, there is a bleed valve right here that you can use to get air out of the system, but they said normally that shouldn't be a problem. So apparently it's cool enough I needed to bleed this, so I unscrewed this 2 turns, pulled the follower knob out, pushed down, and forced it back in, and a little bit of grease came out around the air bleed valve. Then you tighten it down again. Then I started pumping, and we are good to go. I popped over the Chinese mill and used the quick release fitting, and although this style is really tight on it, it's very hard to get off. This one was a little bit tight, but did come off without too much difficulty, so I consider that a win, and this thing really pumps easily, so I'm very pleased with that. It makes me wonder if Zerk fittings, if there's a metric standard and an English standard. This one's from Australia, so you would think it would sort of match, but anyways, I think that's kind of weird. Oh, one more thing. It's my understanding, and I am no expert in this, so don't take my word for it, but that McNaught uses an adapter piece here that makes the thread fitting on here non-standard. I don't know if that's absolutely true. I just read that from a couple of references online, forums. So take it with a grain of salt, but it may be a problem for you, so look into that if you're planning on using a different hose. This one is kind of short, would be handier if it was much longer. Last but not least, I saved what I hope is the most interesting tool for last here, but let me preface this. I bought this tool only because it was really inexpensive. I think I got it for 30 bucks because I actually don't have any use for it, but I love measuring things, and this just gave me an opportunity to do that. I don't know that I'll ever have an actual need for it, but I am kind of excited about it anyways. So inside is a tensile tester. And basically what it does is it tests the tensile strength of materials. So what I believe this was for is not what I initially was thinking was, you know, you get a piece of wire, pop it in here and squeeze this apart. It's more like you'd make a test sample of a known cross-sectional area and then squeeze that, and it measures out up to 200 pounds of force and see when its rupture point is. But I did play with some wire, so here is a piece of soft steel wire, and it looks like it could work for wire only because it's got these interesting jaws on either side. And then you squeeze, and it's ending about 90 psi. Oh, 140. That one held 200. Oh, but it's stretched. So see, this has a very short range of motion, which made me think it might have been for thicker pieces than wire, but I'm not entirely sure. I'll have to check the Winslow website and see if I can, or if they even have one. So there we are, 110, and it stretches again until it keeps deforming. And I know this is a silly tool that I'll probably never have an actual use for, but I find it kind of interesting anyways. 120, 120. Boy, this stuff's really soft. It just keeps stretching. Look at this. There's 200 pounds, but then it stretches out. See it go down? So this stuff keeps deforming because it's really soft. Eventually it's going to break. Oh, heck, let's see if we can break it. So we'll pull it through. Bite it again. Or maybe it's just slipping through. I'm not entirely sure. It does seem to be getting thinner and thinner. I think it's just stretching and deforming. This is really soft wire. There we go. Finally breaks. Look at the cross-sectional area difference. Look how small that is. Look how thick it was originally, if you can see that. Let's see there. Really small. Much thicker. So that was some soft wire that kept deforming. Here is a piece of fencing wire, supposedly good for 150 pounds. Let's see how this one performs. Pretty light gauge wire. All right, let's see what we can get. 60, 80, 100, 120, 140. Feels like it's stretching a little bit. 150 and snaps just before 150. And it didn't actually snap. Well, it snapped at sort of one of the points of the jaws. So it's pretty close to 150. And that's kind of interesting. So that matches. Here's a piece of 5356 welding rod, TIG welding rod, aluminum. And this one is supposedly pretty strong. Stronger than normal aluminum welding rod. Let's see what kind of strength we get. Going up to 100, 140, 160, 180, 2, and it does not break. Oh, look at that. 220 still doesn't break. Okay. I have another kind of aluminum welding rod, which is more pedestrian. This is 4043, I think. So let's cut off a piece of this one. So 220 pounds, 330 seconds. The 5356 welding rod aluminum TIG welding rod would not break. .40, 43, 100, 120, 140, 160, 180, and it broke right at a little over 200. So I guess it's useful for that. I can already tell you the tensile strength of the 5356 filler is stronger than the 4043, I believe, with filler rod. So could use it for that if I want to see which filler metal has more tensile strength. That could be useful. But it only goes 200 pounds, so I don't know if I had to do thick rod like this, probably couldn't do steel. Anyways, thought it'd be interesting. Hope you find it interesting as I do. Thanks for watching. Hope you find it useful. Hope to see you next time.